do one more example. Okay, so one more example. Again, the force versus this example number 4, force versus time graph is given to you. Okay, let's make it a bit complicated like this. Suppose it's like this. This is here. Okay, so this here force as a function of time, and this is time in seconds. Sorry, this is force here in Newton. Force in Newton and time in seconds. Fine. Suppose this is here it will be 40, and take this as, suppose it is equal to 20, and take this as 2 seconds. This is 4 seconds, and this is here suppose 6 seconds. Okay, so first of all, A part is like this. A part. Calculate F. Calculate F at t equal to 1 second. Comma. Okay, only at 1 second. Let's do this. Okay. So B part is like this. Calculate delta P or impulse between t equal to 0 seconds. This here 0 seconds. Between t equal to 0 seconds and t equal to 6 seconds. And C part is that calculate F average between t equal to 0 seconds and t equal to 4 seconds. So 3 different parts you are supposed to calculate. First of all, instantaneous force. Number second, change in momentum or impulse. And number third, average force. Okay. So A part, first of all, we have to calculate the instantaneous force. Instantaneous force कैसे करते हैं? That छोटा triangle, बड़ा triangle. Okay. So simply what we'll do is this. We have to calculate instantaneous force at 1 second. So this will be 1 second. And then make this triangle. Suppose this is theta. तो ऐसे बना लो. Suppose this is here force F. We have to calculate. ठीक है ना बेटा? Okay. So force at 1 second we have to calculate. So I will write like this: tan theta. For the larger triangle, it will be 40 divided by 2. ठीक है ना बेटा? बड़ा वाला triangle 40 divided by 2. छोटा वाला triangle F divided by 1. It's also equal to F divided by 1. 40 by 2 is 20. 20 into 1 is 20. So force F is equal to 20 Newton per square meter. Okay, A part. B part. Next is B part we have to calculate. B part is that we have to calculate delta P or impulse between t equal to 0 second and t equal to 6 seconds. And we know that this change in momentum is equal to impulse is equal to integration of F dt, and that's in turn equal to area. ठीक है ना बेटा? So simply we have to calculate the area under F plus t करो, but keep this point in mind that the area above the time axis is taken as positive and area below the time axis is taken as negative. So ये area ले लो positive and take this area as negative. So first of all, let's calculate the area. Suppose this here A1 and this here A2. Let's calculate A1 and A2 separately. So first of all, let's calculate area A1. Area A1. A1 is a trapezium. So again, it will be equal to 1 by 2 sum of parallel sides multiplied by perpendicular distance. So it will be equal to 1 by 2 sum of parallel sides. Parallel side is this, that is 4, and this, that's 2, because 4 minus 2 is 2, so ये है 2. So 1 by 2, parallel side 4 plus 2, multiplied by perpendicular distance, that is this, which is equal to 40. So multiplied by 40. So 4 plus 2 is 6, 6 by 2 is 3, 3 into 4 is 12, so 120 area A1. And take it positive. So this is positive, ठीक है ना बेटा? Or simply like this, area A1 is 120. Let's calculate area A2. A2 is simply rectangle. So it will be length into breadth. So suppose this is length. So how much is this? This 6 minus 4, that's equal to 2. And this here 20. So 2 multiplied by 20, and that's equal to 40. So that delta P will be equal to I, will be equal to area. And this area is equal to 120 minus 40. Minus isliye because the area below the time axis is taken as negative and the area above the time axis is taken as positive. So delta P will be equal to impulse is equal to 120 minus 40, that's equal to 80. And the units will be kilogram meter per second. So you can answer. Or it is equal to 80 Newton second. We can write like this as well, Newton second. Okay? Take it a bit. So we have calculated the part A and part B. Now part C. Okay, so first of all write it out, then we'll do the part C. यहाँ तक लिखो बेटा, यहाँ तक लिखो. Okay, we have to calculate average force. Average force. C part is that average force between t equal to 0 and t equal to 4 seconds. So C part is like this. We have to calculate the average force between t equal to 0 seconds and t equal to 4 seconds. Not after this. So we have to calculate area only after the 4 seconds. ठीक है ना बेटा? Okay. So average force will be equal to this. That's equal to delta P divided by delta T, and that's delta P is in turn equal to area. So that's equal to area by delta T, but area only after 4 seconds. So F average will be equal to 1 by delta T. Area will be equal to how much? That's equal to 1 by 2 multiplied by sum of parallel sides. So this is here 4, one parallel side, another parallel side is 2, perpendicular distance is 40, divided by delta T. Delta T will be 4 minus 0, that's equal to 4. So this 4 plus 2 is 6, multiplied by 40, divided by 2 multiplied by 4. ठीक है ना बेटा? So this 2 ones are 2, 2 threes are 6, 4 ones are 4, 4 tens are 40, 10 into 3 that's equal to 30 Newton. Answer is 30 Newton. बस हो गया. Done? Okay, so write it down quickly. देखो बेटा ये quickly. Again pause the screen and write it down. We'll do one more last example on this. Last. And we'll do that example which is asked in the AIPMT 2014. So one example is asked in AIPMT 2014. We'll do that. Okay. So the example is like this. Force is given as this is asked in AIPMT 2014. Okay, asked in AIPMT 2014, and the example is like this. That force versus time curve is given to you this here. T versus F. Force is given in Newton and time is given in seconds. Okay. Then the curve is like this. Okay, so this time is given this 6 seconds, this is given this 3 seconds, and this is minus 3 seconds. So this is minus 3, okay? And then this force is given this here, this is, sorry, this is 6 Newton, I'm sorry, this here 6 Newton, this 3 Newton, this minus 3 Newton. So this is given this here 2, this is 4, this is 6, this is 8. And now the question is calculate the impulse. Question is calculate impulse. I is equal to what? Between t equal to 0 seconds and t equal to 8 seconds. 0 seconds and 8 seconds you will have to calculate the impulse. So just ask it in AIPM 2014. Okay, so let's do it quickly. So impulse is simply equal to the area, delta p, and that's simply equal to area. As simply as that. ठीक है ना बेटा? Delta p integration f dt, and that's equal to area. So let's calculate the area. Suppose this area A1, this is area A2, this is area A3. First of all, separate we will calculate the area A1, A2 and A3. Then take this positive, this negative. ठीक है ना बेटा? Okay, so area A1 will be equal to 1 by 2 sum of parallel sides. So this from here to here, this is 4, this is 2. So that will be 4 plus 2 multiplied perpendicular distance, that is this. Yeah, 6. So 6 here, so 4 plus 2 is 6. 6 into 6 is 36. 36 divided by 2 is 18. Then calculate area A2, this one. So from here to here, this is 2. From here to here, this is 3. So it will be 2 multiplied by 3, that's equal to 6. Area A3. This one again length into breadth. So from here to here it is 2. From here to here it is 3. So 2 3s are again that's equal to 6. Okay. Now delta P will be simply equal to area or impulse, that's equal to area, which is equal to A1 minus A2 plus A3. Because take this area as positive, take this as negative because it is below the time axis, take this as positive because it is above the time axis. So impulse कितना निकला बेटा? Impulse is equal to A1. That's 18 minus 6 plus 6, that's equal to 18 kilogram meter per second. तो ये आंसर बस हो गया. Easiest of the lot. Last students, AIPMT 2014. Done? Okay, again pause the screen and write it down. So till now we one with the Newton's second law of motion as well as with the Newton's first law of motion. Okay. Now we'll switch to another topic, and that's called as this free body diagram. Okay. Okay. So look a bit of free body diagrams. Free body diagram. Free body diagrams are denoted by FBD. FBD. It's very important topic. Okay. Free body diagram or FBD. Because number one, it's important. Continuously questions are asked in the NEET, in AIMS, and in JEE and as well. Continuously the questions are asked on this topic. Okay. Number one. Number second is that it has its application in the work power energy, in rigid body dynamics, in gravitation. Everywhere it will be used. In almost every chapter of physics, the free body diagrams will be used. Okay. So it makes it highly important. Very important. Okay. So before going into the free body diagrams, let's first of all have a clear concept of the forces which we use in the mechanics. Okay. So here I will write down 6 different forces. 6 forces in mechanics. 6 different forces in mechanics. 6 forces in mechanics which will be continuously used. 6 different forces in mechanics. For example, force number 1 is weight. Force number 1 is weight, denoted by mg. Force number 2 is called as normal force or normal reaction. Normal force, or it's also called as normal reaction. Normal reaction, denoted by m. Number 3rd force is tension in string. Tension in string. In string, denoted by d. Number 4 is spring force. Is spring force, which is denoted by Fs. Force number 5 is called as pseudo force. Pseudo force. It's not a real force. It's not a real force. Pseudo force is not a real force. But we define it later on. You will come to know when we'll define what we mean by inertial and non-inertial frames of reference. Okay, then comes the in that very case we will define the pseudo force. Okay, in case of non-inertial frame of reference or accelerating frame of reference. So pseudo force, denoted by this Fp, pseudo force. Number 6 is there. Number 6 is there. That is frictional force. Frictional force. Frictional force here. Okay, frictional force here. So these are the 6 different forces which will be dealing with in the Newton's in the Newton's laws of motion. Okay, so in NLM first, in second, and as well as in third, we'll be dealing with all these forces. Okay. Then there will be one more force that's called a centripetal force. Centripetal force, but we'll discuss that in the NLM third, that is circular motion. Okay. Okay. So then all these forces, all the 6 different forces, they are classified in 2 different categories. All forces, all forces are classified into 2 categories. Into 2 categories with a contact force, and B non-contact force. Non-contact force or action at a distance force. Distance force. Contact force or action at a distance force. Simply, what we mean by contact force? Contact force implies that force which has its existence only if there are 2 different objects which are in contact with each other. 2 different surfaces are in contact with each other. So contact is very necessary for the contact force to exist. And non-contact force are those forces which don't require any physical contact to exist. Okay, they can exist even if there is no physical contact between the 2 different objects. For example, weight is there. This weight is a non-contact force. Okay, so here I will write down this one is a non-contact force. This one, normal force is a contact force. Tensional spring is a contact force. Spring force is a contact force. Pseudo force, it's not a force. So here I will write down not a real force. It's not a real force. So we cannot say whether it's a contact force or a non-contact force. The frictional force is indeed a contact force. Okay, so among all these, the force that is non-contact force is the weight. What is the non-contact force? Because, for example, here we have this horizontal surface. Now there is a block placed on this. Okay, its mass is m, so the weight will be the vertically downward direction. That's mg. Okay, whether you place this block on the table or you hang it in the air, the weight will be still there. Implies that the weight, it doesn't matter that whether it makes a physical contact with another surface or not, the weight will still exist. In the same way, for example, there is a gravitational force between two different bars. This m1, this is m2. The two objects will attract each other by a force that's called as gravitational force, and this gravitational force is a non-contact force. There is sun and there is earth. They are millions of kilometers apart, but still they exert a force on each other and imply that force is a non-contact force. Okay. In the same way, for example, there is electrostatic force. So यहाँ पे लिखो बेटा, this here weight is a contact force. Mg is a contact force. Sorry, is a non-contact force. It's a non-contact force or action at a distance. This gravitational force is also a non-contact force. In the same way, electrostatic force, for example, this is charge q1, this another charge q2, they will repel each other, though there is no physical contact between them, implies that it's a non-contact force. ठीक है ना बेटा? Non-contact force. Electrostatic force, वहां पर लिखो, electrostatic force is a non-contact force. In the same way, magnetic force, for example, there are two different bar magnets. They will either attract or they will repel at a distance. Physical contact is not necessary. Implies that force is again what? A non-contact force. Okay, so that's a non-contact force. Okay, so what are the examples of non-contact force? First of all, gravitational force or weight, that's one and the same thing. Number second is that electrostatic force. Number third is magnetic force or magnetostatic force. That's what? These are all non-contact forces. Or these are action at a distance. Okay, then the remaining forces, they are all contact forces because they require physical contact between the two. Okay, for example, if there is no physical contact between a vehicle and a road, the frictional force cannot exist. It exists only if there is a physical contact between the two. Okay, so remaining examples are all non-contact force. So simply all the forces are classified in two categories: these contact force and non-contact force. Contact force is that force which requires a physical contact for existence, and non-contact force implies that force which does not require physical contact for existence. Examples are weight or gravitational force and electrostatic force, magnetostatic force. These are all the examples of non-contact forces. And contact force implies that force which requires a physical contact. Like there is frictional force, there is tension in the string, there is spring force. Okay, you will come to know with time that really they are the contact force. Okay. So let's discuss each of these forces one by one. Okay, so we'll start with the weight and then the normal force, then the tension string. But these three forces, that is spring force, pseudo force, and friction force, we'll discuss them later on when we'll repair them. Okay. So I'll wrap this off now. Now you just pause your screen and write now. यहाँ तक लिखो बेटा. Okay. So I'll start with the weight. Okay. So first of all, underline weight. So first of all, number one is that weight. So point number one in the weight is there. Point number one, it is a non-contact force. First of all, right now it is a non-contact force. Non-contact force. What do you mean by non-contact force? Imply that force which does not require any physical contact for existence. Okay. So point number two is the definition of the weight. What is the definition of the weight? Definition of weight is simply a force with which an object is attracted towards the center of Earth. As simple as that. Okay, na beta? Like this, for example, here we have this horizontal surface and this is a block. Okay, its mass is equal to m. It is attracted in the downward direction by Earth by a force m multiplied by g, that's equal to w. So this is weight. So simply, what the definition of the weight? Definition of weight is that it is the force. It is the force. It is the gravitational force. Gravitational force with which an object is attracted by Earth towards its center. Simplest definition. Okay. Now next is that what's the magnitude of this? W is equal to m multiplied by g. and in vector form you can write like this, implies that the direction of the weight is same as that of the direction of the acceleration due to gravity. Okay. Number third is that important point, and that's about the direction. देखो बेटा, direction of weight is always vertically downwards. Direction of weight is always vertically downwards. Always vertically downwards. Always vertically downwards, or perpendicular to horizontal. That's one and the same thing. If it's vertically downwards, it implies that it is perpendicular to horizontal. Like this, it's vertically downwards and normal or perpendicular to horizontal. So we're done with the weight. First of all, it's a non-contact force. It's a gravitational force with which an object is attracted to the center of Earth, or vertically downwards, and its magnitude is W is equal to M multiplied by G. Vector implies that the direction of the W is same as that of the G acceleration due to gravity. So direction of weight is always vertically downwards or perpendicular to horizontal, as simple as that. Okay, so we're done with the weight. Okay, now force number 2. Force number 2. Force number 2. Look at force number 2. Force number 2 is what? Normal reaction. Force number 2 is normal reaction, that is denoted by N. Now what do we mean by normal reaction? Normal reaction simply implies that it's a pressing force between two surfaces in contact. As simple as that. Suppose that I apply force 10 Newton on this board. The board will in turn apply 10 Newton force on my hand in the backward direction. Newton's third law of motion, to every action there is an equal and opposite reaction. So I am applying 10 Newton inwards. The force exerted by the board on my hand will be 10 Newton in the backward direction, and that's called as normal reaction. Simple, okay? So how to define it? It is a, first of all, point number 1, it's a contact force. It's a contact force. Contact force implies that it will exist only if there is contact between two objects or between two surfaces, and it will not exist if there is no contact between two surfaces. Okay? So number 1. Number second is that, second definition, it is a pressing force. Look at it. It is a pressing force. It's a pressing force that exists between two surfaces in contact. ठीक है ना बेटा? Okay. Or you can write down one more definition, or it is a normal component of contact force. Later on, when we study the friction, you will see that there is a contact force between two surfaces in contact, and this contact force is resolved into two rectangular components. One is normal, another is horizontal, another is parallel. And the normal component is normal reaction, and the horizontal component or the parallel component is the friction. Later on, you will see. Okay. So it's a normal component of the contact force, or it's a pressing force that exists between two surfaces in contact. Okay, so that's called as normal reaction. Now what about the definition? Definition simply is that, what about direction? What about direction? It is always perpendicular to plane of contact. Okay, not necessarily vertically upwards. So simply it's perpendicular to the plane of contact, but it's not necessarily that it's perpendicular to it is vertically upwards. Okay, so let's quote some examples so that it will be clear to you what actually normal reaction means to us. Okay, so example number one. Suppose that this is a horizontal surface and a block is placed on this horizontal surface like this. Okay, ठीक है ना बेटा? Okay, this is a block. Now the force acting on this is weight in the downward direction. Okay, so the block exerts a force on the horizontal surface in the downward direction, and this horizontal surface will exert a force in the vertically upward direction, and that's called as normal reaction, which is perpendicular to plane of contact, and this is plane of contact. Okay, since plane of contact is horizontal, so obviously normal reaction is vertically upwards. Okay, example number 2. Example number 2. Suppose that it is like this. Here we have this a block. Okay, this a block here. It is pressed against this wall, against this vertical wall. like this, a force applied in this direction which is called F. So let me test against this. Okay. Now there will be two different normal reactions. One normal reaction along this direction, suppose that is equal to N1. Another normal reaction in this direction, suppose that is equal to N2. So simply a pressing force that is perpendicular to the plane of contact. Okay, so it's perpendicular to plane of contact, perpendicular to plane of contact. Okay, so it's clear from here that it's not necessary that the normal reaction is vertically upwards. This normal reaction is vertically upwards, but this is horizontal. Implies that it's not necessary that it's vertically upwards, but what's necessary is that it is perpendicular to the plane of contact. Okay, example number 2. Okay, so later on we'll go to many examples, then we'll construct the free body diagram. Okay, so it's example number 1 and example number 2 there. Or for example, here we have this inclined plane like this, and this is a block placed on the inclined plane like this. Okay, this inclined plane and the block is placed on the inclined plane. Now this is the plane of contact. So weight is always vertically downwards, implies weight is in this direction. But the normal direction is not perpendicular. It's not vertically upwards, but it is always perpendicular to the plane of contact. That means it will be in this direction. So in this direction there is normal reaction, it is perpendicular to the plane of contact. We will see here in this direction. So this example number 3 of this normal reaction. Okay. So force number 1, force number 2, we are done with this. Okay. Now force number 3. Look at force number 3. Write down third force. First of all, write it down. Pause the screen and write it down. Okay. Now we have what? Force number 3. Okay, force number 3 is what? Now what's force number 3? Force number 3 is tension in string. Tension in string. Tension string denoted by T. Okay. Simply tension string is a pulling force. Suppose that you have a string, you pull it with a force of 10 Newton. This string will in turn pull you backwards with 10 Newton, and then the reaction force in the backward direction, that's called tension string. Okay, simple. Okay, so point number first is that it is a contact force. It is a contact force. Contact force implies that if you pull the string, there's tension string. If you will not pull the string, there will be no tension string. Okay, so for the tension to exist, a physical contact is necessary. Only then the tension can act. Okay, so it is a contact force. Okay, so number second is that. Now, for example, here we have this rigid support here. It's like this is a rigid support. Now this is string, okay, and you are pulling the string in this direction. You are exerting a force in this direction, external force, that is equal to F. Okay, now the string will in turn pull you in the backward direction, in this direction. Okay. It's called tension string. Simple, okay? So next point what I will write is this. It is always pulling in nature. It is always pulling in nature. Pulling in nature. It is never possible that with the help of a rope or with the help of a string you can push an object. Okay? But you can pull an object. For example, there is a block. A string is connecting the block. You can pull the block with the help of string, but you cannot push the block with the help of string. Implies that it's always pulling in nature. And number 3 is that it is an intermolecular force. It is an intermolecular force. Intermolecular force. It is an intermolecular force between molecules. It is an intermolecular force between molecules of string or rope. Between molecules of string or rope. So it is an intermolecular force between the molecules of string or molecules of rope. Okay, so write it down. So we have defined the 3 different forces. Now write down important point about the tension string. And that important point is that if the string is massless, then the tension throughout the string will be constant. And if the string is massive, then the tension throughout the string will not be constant. Okay? Okay, so write down this important point. Write down this important point. Point is like this. If string is massless doesn't imply that its mass is exactly equal to 0. But massless implies that, for example, here we have this is a block, and now you are pulling this block with the help of a string. Suppose the mass of this is equal to 100 kg, and this string, its mass is 0.001 gram or 0.1 gram. Let's take it 0.1 gram. So obviously the 0.1 gram is very small compared to 100 kg. So we assume that the mass of the string is equal to 0, or we say that the string is massless. So if the string is massless, then tension in string is constant. The tension in string is constant throughout the length of string. The tension in string is constant throughout the length of string. ठीक है ना बेटा? And if string is massive, massive implies that it has some mass. Then in that very case, then it is not constant. Then tension in the string is not constant. Simple, okay? So let's have a simple proof for this. Simple proof here. ध्यान रखो बेटा. A simple proof for this. Okay, so छोटा सा proof. For example, here we have this string for a rope. Okay, now two different forces are applied. Suppose at this point there is one force, at this point there is another force. This is T1, this is T2. Two different tensions. Okay, two different tensions. And let's suppose that T1 is not equal to T2, and let's assume that this T2. Is greater than T1, and T2 is greater than T1. It's obvious that it will accelerate in this direction with an acceleration of a. Suppose its mass is m. ठीक है ना बेटा? Okay, so simply I'll use the Newton's second law of motion, and Newton's second law of motion is mass into acceleration is equal to net force, or summation of all forces. Simple. So mass into acceleration will be equal to, अब ध्यान रखो बेटा, summation of all the force implies T2 minus T1. ठीक है ना बेटा? Net force, if this is 20 Newton, this is 10 Newton, so net force will be 20 minus 10, that's equal to 10 Newton. So T2 minus T1. Now there are two possibilities. Possibility number one, point number one, if mass of string is 0, that means it is massless. In that case, this will be equal to 0, so T2 minus T1 will be 0, or it means that T2 is equal to T1. That's what I'm saying. If the mass of the string is equal to 0, then the tension throughout the length of the string remains constant. And if point number 2 is this, if mass is not equal to 0, then obviously T2 is not equal to T1. ठीक है ना बेटा? Okay, so important point here is that if the mass of the string is equal to 0, then the tension remains constant, otherwise not. But in NLM, we always assume that the mass of the string is 0, so that the tension throughout the string remains constant. ठीक है ना बेटा? Okay, so we are done with with the first three forces. That's number one, weight, and number second is normal reaction. Number third is tension string. Okay, so weight is simply mg, always vertically downwards. It's a non-contact force. Normal reaction contact force. It is always perpendicular to the plane of contact, not necessarily that it's vertically upwards. ठीक है ना बेटा? And number third, the tension is simply a pulling force. You pull a rope, the rope will enter pull in the backward direction, called as tension. Okay, an important point to remember is that the tension of string in the string remains constant if it is massless, and it does not remain constant if it is not massless. ठीक है ना बेटा? Okay, so we are done with the basic definition of the three body diagrams. Okay, so now there are three more forces. Those three more forces will be introduced later on, and we'll require them. ठीक है ना बेटा? We are left with pseudo force, we are left with spring force, and we are left with the friction force. Okay, then there is one more force, that is centripetal force. We will discuss the centripetal force in the circular motion in the chapter number 3 of Newton's laws of motion. Okay, so pause.